Hello, my name's Steve Drain and I'm with MarQuest Limited. Today we're going to have a look at using InterMapper to gain real-time network knowledge and visibility into your network. So let's start by creating a new map. Now for the purpose of this, I'm going to build a map on my Oxford office, so let's call it Oxford. We're then given three options: auto-discover, manual entry or import a file. We're just going to go with the auto-discovery today. What it then does is it will present to us an option, so we can enter in either an IP address or a subnet that we can start the auto-discover from. We can provide an SNMP community string. The point of this is if we have routers or switches on our network, InterMapper will try to obtain information about the interfaces on those devices and what's connected to those interfaces, what networks are at the end of those interfaces. And that's where this next option comes in. We can choose how many hops from those network devices it will then try to traverse to try and find out more information. I'm only interested in the local network today, so we'll keep this within one hop of the starting device. I'm also going to keep it as a public community string, which should maybe show at one device, maybe one or two, but we're going to add the routers and switches in manually later. And we can edit filters. We can choose how we want it to filter devices, what device we want it to ignore. We're going to choose automatic layout as well. For this purpose, because we're not going to pick up any, or we hopefully shouldn't pick up any SNMP enabled devices, it's just going to arrange everything around a subnet. So, what happens now is InterMapper will go away. The first thing it will do is it will try and use the community string to identify routers and switches within the IP range that we've specified. And then, as I said before, it will try to identify networks on the end of those devices. Once it's scanned successfully or failed to detect these SNMP enabled devices, it will then launch a ping sweep across the network in order as you would expect. And as it does this, it will also perform DNS lookups as well to try and give you a bit more knowledge about what the actual device is. As you can see here, we've got green icons and question marks. Well, these relate to the different notification statuses that devices can have. So we have a down, critical, alarm, warning, OK, or unknown state. These two relate to if a device has gone down and you've acknowledged it, or if it's unacknowledged. So at the moment you can see all of these devices are coming up as green because they are OK. Previously we had a couple of question marks because they were unknown. That's because InterMapper had pinged them but hadn't necessarily received all of the packets in response yet. If a device was, say, had high latency to a ping request, or it was dropping packets, it wouldn't come back as OK or unknown. It would start to drop into the warning alarm state depending on what threshold you set. So the device list that we're looking at the moment is called the list view. Let's switch to the map view. This is where people really get the value out of InterMapper, because this is where you can start to see what's going on in your network, where things are positioned in your network and their potential knock-on effect on other devices. And you notice here this device has actually gone into a warning state. And what we can do is we can right-click and view the status window for this, and we can see it's because it's had a response time of 1,577 milliseconds. And so this is obviously within the thresholds for that device, and it's gone to warning. And we'll have a look at that again later. By default, all of these now should have a ping probe, apart from perhaps our printer, which has still got a public community string. And again, as I said, it's arranged everything around the subnet. So if we have a look at our switch now, for example, if we right click and go to status window, we can see that we've got some detail here. So we've got a name, an IP address, its status, and we can see the current probe that's applied to it is a ping echo. Its availability, well, it's 100%, which is great. It's been running the whole time we've been going. And we've got some response times as well about the ping. But actually I want to get a little bit more information about my network and what's going on. So first thing I want to do is navigate to my server settings. And I want to ensure that something called Layer 2 is enabled. Layer 2 allows us to augment the information that we've got. We take it from the IP layer and we start to move into MAC addressing, and we start to see the connections between interfaces and devices. And it's set to update manually. You can change this to once a day, every 5 minutes, however long. Obviously this will have an impact on your switch if you have a large switch, a very active switch. So I'm just going to leave that as it is at the moment. And I'm going to come back here and I'm going to right click. I'm going to go to set info and I'm going to set a probe on it. So as I said, we've got a ping echo probe already set, and there's a few variables that you can change on this. I'm actually going to apply what's called an SNMP table viewer probe to it. And this is going to go away and it's going to pull down all of the detail that it can from the SNMP device. There are quite a few different probes available which you can apply to devices as well. We've got some basic TCP, so if you want to monitor a TCP port or a web server, these are great. You can actually go away and try and access a web page on HTTP, some DNS lookups, FTP, and so on. So there's a lot of a lot of default probes that come with the application to allow you to poll these devices, and you can write your own custom ones. You can write them using their probe language. You can use SNMP. You can use Python if you wanted. To actually make your own very specific probes to do what you want to do. Perhaps you wanted to connect to a device, log in, do some action, and then set the status level of the device based on what the response was, and you can do that with a Python probe. So if we go back, we're going to set a table viewer. That's version 2 that we're running. So if I enter in our community string and hit OK, now that goes away and dub. We suddenly have all these interfaces attached to it. Look at that. Now these ones with the crosses through are indicating that nothing's connected to them at the moment, and you can see these ones here should have something connected to them. But you know, we're not looking at layer 2 information on the map level yet. We've enabled it for a server, but this is an individual map and we have to make sure it's enabled on that. So before we do any more, let's have a look at the status window and just see what else it's telling us now. So you've got all of these different tables available to view now, and obviously the information available on these depends on what the device provides, what type of device it is as well. Obviously routers are only going to provide some of these. Here's our interface table. We can see the index, the description, the type, the speed, MAC address, and its current status as well, which is great. That gives us real visibility and information on the device. Extended interface table, and so on. There is a ARP table available as well. Obviously on a router this will be more significant. On this is going to be just from the management interface. And at the bottom here we can see a summary. Why is it currently in a different status? Well, it's got a link down, and these are the different links that are down at the moment, but that's because there's nothing connected. In the meanwhile, you may have noticed in the background we've suddenly got ants running around, and this is giving us an indication of the utilization of our links. And if we right click and go to status window on the link, here we go. We're actually getting some information now, some statistics being generated about these links. It's telling us what's going on with these, bytes transmitted, received, errors, and such like. So this is cool. We're getting some information now, but it's still not really giving us a full picture. So let's have a look at our map settings. And here we want to look at layer 2 features, and you can see they're not enabled. They have to be enabled on a server basis and then enabled per map. So let's enable them. We want to automatically change the map to show layer 2 connections. That's fine. Show interfaces when a connection's made. So if an interface which currently has no connections is hidden because we've selected this second option, if something is then connected, someone's in a hot desk environment or you've just added a new server, the interface will come up. And let's hide some of our prop virtual ones. And if we hit change now, nothing happens. Because you may recall when we go back to our server settings, we still have our layer 2 polling set to manually. So if we change this to once a day at midnight, so we have minimal impact, again you'll know better than anyone else, you know, how often you should collect this information. But if we hit now, it will go away and it will poll this switch to try and get all of its layer 2 information down, and you may have noticed that something's happened in the background. Suddenly it's actually started to match these devices up, and what it's done is it knows what MAC address is connected to each interface. From the local ARP table on the machine and the ARP table available on any of your layer 2 devices such as routers or switches, it knows what MAC address matches up to what IP address. And we've already got a list of IP addresses because each of these devices have been pinged, so we know that they have an IP address. And by definition, if we've been able to ping them from this server, well, they're going to be on our ARP record. There's some here which we haven't got records for, which will be either because they've not connected or it's timed out. We've got this one here. We've got actually 2 devices coming off, and that's just going to simply be because it's a wireless access point, for example. And so suddenly you're starting to get a lot more visibility on what's going on in your network. What you can actually do as well is you could select everything and go to format and arrange everything organically. And there's a couple of different styles that you can use to arrange these as well, depending on how you want your network to look. But the real power of InterMapper isn't in using these automatic layout options, is in actually laying it out yourself, laying it out in a way that makes sense to you. So let's look at our switch. Let's go back to that, and let's change the icon on it. There's lots of built-in and default icons already, and here's a switch. You can choose the size of it based on how important it is in your network, and let's go for that. And we can now go in and we can change the label if we wanted. So it uses the smart name. What is the smart name? If you select down here this list of variables available, it's the device's DNS name, SNMP name, or address in order. What you could actually do is you could go Oxford Core switch, and it will present it exactly how you've typed it here. And there we go. And that's not still great. We might want to reposition it and put it below. Now we're starting to get a little bit more use out of this. An Oxford desktop, we could change the icon of this. And again, there's a whole host of icons available. So this one is Oxford Desktop, and that's a Windows machine. I know that because it's a machine that we use in our office, and I can change the icon to represent that. Again, I could organize the label position and put it above the desktop. So you see, now we're very slowly starting to build up the information that this gives to us. Now at a very quick glance we can see which devices are Windows, which are switches, etc. So let's go back to our switch. Now, we looked earlier by going to the status window. We can actually see, okay, we've got utilization rates, 100 meg link, percentile error, and all of these are underlined. So for example, if we click on the 100 meg link, it allows us to change the link speed. Okay, well that's interesting, but why would I want to do that? Well, 2.1 is actually our firewall, and in the office here we only have a 1 meg link. So if I'm monitoring my network, the 0.18% utilization is actually meaningless. It's not actually a true representation of the utilization. So I'm going to change this to a 1 meg link. Suddenly the utilization rate is now correctly reporting what the utilization is. It's giving me a realistic view of what I'm using on that port, which is important to me. The fact that it has 100 meg by default is because it's done the query and it knows how fast the link can go. But now I'm actually getting much more representative data, and I can click on this blue link and I can actually create a chart. And now from this point it will start charting all of our utilization over time, and I can right click and go to chart options. I can choose labels for the vertical axis, the time axis. We can choose all sorts of different values, data, colors. If I wanted, I might be interested in percent error. I can click and drag this onto the same chart. And now if I close this, that will always be charting. It's available here. And there's lots of other things that you can do with InterMapper as well to augment this. You can start to use attach tos, and you can join this to other devices if you want to start to create logical links as well to show how your devices coexist within your network. You can really start to reattach things if you want to create some more intelligence. Let's say that I wanted to attach this to here because it's an access point. I might want to format the icon of it. And you can start to create your own. So if we go format icon, could change this one just to text, format the label, get rid of the label altogether, put this here, and there's our access point holding two devices. And the great thing is that we are getting utilization rates based on this, and we can set our data retention and link speed. Now earlier I talked about thresholds, so if we have a look at 101, we could go to set info and set thresholds. It's going to use the map defaults, but I could actually specify custom thresholds for each of these states. So obviously we saw it was in 1500 earlier, so if we change that to 2000, it changes to OK. If you're monitoring over a VPN or a high latency link, you may want to increase some of these variables. And as I said, you can come into server settings. You've got lots of device defaults, network defaults, device threshold defaults, and these are inherited by default until you start changing them. Something else that you can do as well is you can have notifications. So let's say I now wanted to monitor this. I could go to the notifiers window, and we've got sounds by default, so let's edit our notifiers and let's add a new notifier. And by notifier we could have an email sent, an SMS if we were using an SMS service, You could send a trap, syslog, you could run a script, whichever. So at the moment we could say email, we could send it to Bob at MarQuest. We could even change the format of the message. So here we go, again, the same as the labels, we have all these different variables available to us, which we can select, and it will give us information on. And we can double click to add these as well if we really want them. And we can just mess around with it and do all that, and we can change the subject. So we can really specify what the format of the message is. Also, say for example, we know this might be a workstation and we don't actually want to monitor it after hours. We can just click and deselect. So suddenly we're not actually notifying if anything happens over those hours. And we can call it email. Click OK, that adds it to the list. And now what we can do is, okay, we want an email notification whenever it goes down, comes up. We want you to wait 5 minutes before sending a notification, just in case it comes back up. Or we want you to repeat every 5 seconds, every 30 seconds, every 12 hours. Maybe repeat it after 5 minutes, so we know that it's, it's not been dealt with. And a count, we could set it to infinity, we could repeat 5 times. And the reason you might want it to repeat is because you need your operations guys to acknowledge it. They would come in here, right click, and acknowledge the device as being down, which means that they're handling it, they're dealing with it. If it was a critical server, that gives information to the team that it's been acknowledged, it's no longer an outstanding issue, somebody's dealing with it. Finally, there's still a lot more I could talk about with InterMapper, but I just want to show you that we have got user permissions. So you can create different user accounts. You can tie this into an LDAP server as well if you wanted to use LDAP. And you can create map access rules. So you can set access by user to different maps. There is a web interface available as well, and a remote access client. And you can change, if you have different users, what their permissions are. You can change their permission per map as well. And that is a very quick intro on InterMapper and how to get started with your first map. If you had any other questions, please come and find one of us and we'll be sure to help. Thank you very much.